Hi everyone, this is video 2 of our notes B, and this will be all about our exponential equations. Last one was about linear, this one is about exponential. So again, just like linear, we're going to have two separate equations that represent exponential. And then we're going to do some examples with the actual numbers in the equation. So our two equations are called the base equation, and then our second equation for exponential is called percentages. So let me show you this slide, just like last time. This is what the base equation looks like for exponential. So notice it looks different than linear. Linear, if I can go back real quick, was a straight across equation, y equals mx plus b. Exponential's a little different, right? I'm still seeing a b, that looks familiar, but I'm now seeing parentheses and I'm seeing this x up high in the exponent. Whenever you see a letter up high or a letter in the exponent, that means it's going to be an exponential equation. So just so you know, if you see a letter up high, exponential, okay? So just like last time, I want to find this equation and I want to put it in my notes for this section. So again, it's y equals b times a to the x exponent. I know that sounds kind of weird, but the x is in your exponent. So in our notes, let's go ahead back to slide 8, that blue slide, and let's find this equation. If you look, this equation is up here in the top right-hand corner. I'm going to copy it, and I'm going to go ahead and put it in my slide for exponential. So there's my basic exponential equation. We're going to see this a lot over and over and over again. Now, just like linear, there's also an equation that's not used as much, but it is still considered exponential. And that has to do with percentages. If you ever see a percent sign, you're going to have to use this equation. So back to our slide here. This is what the percentage form looks like. There are two, but it's just because one represents if you're increasing or getting bigger, and one represents if you're decreasing or getting smaller. The only difference is the increasing has a plus sign and the decreasing has a minus sign, but everything else is the same. And I want you to notice the reason this is exponential is because I see a letter in the exponent. Okay, so again, we're going to find this equation and we're going to copy and paste it. So this equation is in the bottom left right here, has the increasing, decreasing, and we're going to paste that in our percentage. Again, it's one that you won't see that often, but it technically is an exponential equation, so I want you to be able to look back at it. The one that we're going to see the most is this basic one. And this one is also labeled. It's labeled with our y-intercept starting value, and it's labeled with our rate of change. So let's look at some problems that have numbers in them. So here we go again. These are all exponential equations. The reason I know it and the reason you should know it is because all of these equations have that x up high, okay? Linear did not have the x up high. Exponential has the x up high, or I should say any letter. It could be an a up high, a b up high. It should have a letter up high in the exponent, okay? So here we go. Our first equation here says y equals 2 times that parenthesis 3 and the x up high. The first question I'm asking is, what is the rate of change? Well, let's go and look at our picture. I see right here, this picture is saying the rate of change is pointing to, for this picture, it's whatever's in the parenthesis, but I want you to think about, again, whatever number is attached to x, okay? Because there's not always going to be a parenthesis, but I want you to think about what number has that x attached to it. So in this situation, that's going to be the number 3. That has that x attached to it, okay? So our answer for the rate of change is going to be 3. Next one is asking, what is the y-intercept or the starting value? Well, back in our picture, the y-intercept or the starting value is that number that's not attached to x. It's usually the number out front, but again, it's the number that's not attached to x. Just in case it's not out front, it's the number that's not attached to x. So for us, that number that's not attached to x is the number 2. So that's going to be our y-intercept or starting value. Again, pretty easy. Look at your picture, look at what it's labeled, and that's your answer. Next one, same kind of thing. My equation is y equals 1, parentheses 0.5 to the x power, that exponent up there. The slope rate of change, remember that's whatever is attached to x. For us this time, it's 0.5. And then the y-intercept starting value is, again, the number that's not attached to x. So this time, that's going to be 1. Okay? Again, 2 more problems. They're you do problems, so on your own. The one thing I want to say is this problem here, if you notice there's 2 parentheses, don't freak out. Think about what number is attached to x and what number is not. Okay? The one attached to x is your rate of change. The one that's not is your y-intercept. So I don't care if there's 2 parentheses, no parentheses. Think about what you know. What's attached to x and what is not. Good luck.